I expect a 90 plus, but in like in maths, I expect a 50 or a 60 plus.
Oh, okay, sure, sure. Why?
Um, because maths, like I attempted like 16 or 17 questions out of 25.
Okay, 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 okay. But that is correct, no? Like, try to not to lose marks in negative, in wrong questions, attempting wrong questions like that. If you don't know, you can leave that.
Yeah, if I don't know, I can leave. That's what JEE
Perfect.
mains and advanced kids do.
Perfect. So, where were we? We
Uh,
did, yes.
so wait, where were we? We were in root of four. Wait, I think we finished velocity wave number. We did wave number. We finished the wave number and sums also we did.
Okay, okay. Shall I give you one question?
Yes, sir. Sir, uh,
Yes.
um, uh, the test of chapter one will be on next Wednesday, right?
Next Friday, I'll give next Friday.
Next Friday?
Wednesday, yeah, I always take test in weekends so that when the time of checking will come, na, then it will be easy for me. Saturday, Sunday is holiday for me, na? Because Wednesday, if I will take, then uh, Thursday, Friday is very hectic for me to check.
Sir,
So, yes.
I have Allen's on Mondays, Tuesdays, Thursdays, and Fridays.
Hmm.
So Wednesdays I'm free. So
Okay, okay. So we'll do one thing. I'll give you test on Wednesday, if possible. If I'm making, I have to be in habit to make to give you test on Wednesday, and then but I will check after Sunday only. Okay. So like Thursday, Friday, I will not able to check because I have other works. So but Saturday, Sunday, I will check it and then I will send you the results. Will it be fine?
so you'll send the paper on Wednesday. I'll complete it on Wednesday, and you'll check it only on the Saturday, Sunday.
Yeah.
Okay.
Will it be fine?
Yes,
Perfect.
fine. Yeah, fine with that.
Okay. So now we'll solve this question. Yes, guys. Edik,
Yes,
solve
sir.
this. This is the question.
Okay. Done, sir. Done, sir.
Done?
Yes, sir.
Okay, what's the answer?
So wavelength is 8.64 picometer.
Picometer, correct. Okay, now put a heading, properties of a electromagnetic waves. So they can ask you like what are the properties? Okay, so you have to remember this. So put a heading, properties of properties of electromagnetic waves. Okay, so the first property is I will try to make this picture to show you the propagation of the wave. Okay, okay.
Yes.
So basically, remember this thing. This is x axis, this is z axis, and this is y axis. Okay. Now
Yes.
x axis is basically if the particle is moving, so the propagation of that waves. Okay. So direction of propagation. Direction of propagation is the basically x direction.
Yes.
Now, how this electric field will move? So electric field will move like this. I hope I'm able to make the correct
Yes, sir.
diagram.
So electric field means it is called the Stark effect, but magnetic
Yes,
field means it is called the Zeeman effect.
Z-man effect. Perfect. And the this thing, which thing? This one will be the. I hope. Oh, this is very bad diagram. Ah, come on, yeah. Okay.
Yes.
So this is basically the propagation of the light. Look like. Okay. I'm
Yes.
very bad in diagram. Sorry for that.
Oh,
Okay.
you said that you always used to get D in your drawings. Oh,
Mm, that is why. My
right.
bad. Okay. So now can you write some properties? I'm dictating. Write it
Wait,
down.
wait.
Hmm.
I still need to draw this, sir.
Okay, okay. Draw it better. Till then I will open the that thing.
One minute.
Done?
Yes, sir. Done.
Okay. Now write it down. The oscillating electric and magnetic field,
The
the
all.
oscillating,
Yeah.
the oscillating electric and magnetic field generated by oscillating charge particles, the oscillating electric and magnetic field generated by oscillating charge particles to each other are perpendicular to each other
The oscillating
as well,
the oscillating electric and magnetic field.
and by oscillating charge particle are perpendicular to each other and also to the direction of propagation and also to the direction of propagation. Second point, these waves do not require medium. These waves do not require medium. Okay.
Yes.
These waves is also called as do not require medium.
Yes, sir.
Okay.
Yes.
Now next thing, when electromagnetic radiations are arranged when electromagnetic radiation are arranged, increasing wavelength are arranged in increasing wavelength or decreasing frequency because we know that wavelength is indirectly proportional to frequency.
Sir, inversely
No,
proportional.
no, inversely proportional.
D-
Yes, correct. Speed is directly proportional to frequency, but wavelength is indirectly proportional to frequency. Got it?
Yes. Yes,
No.
sir. Yes, sir.
Hmm? So if frequency is there, then the speed of the radiation will be more.
Yes.
Okay.
Yes, sir.
Now, what was I saying?
When electromagnetic radiations are arranged in increasing wavelength or decreasing frequency.
Okay, the complete spectrum is called electromagnetic spectrum. Electromagnetic spectrum. So basically, we have many rays which have their specific wavelength, and when we are arranging them, that is called as electromagnetic spectrum. So, for example, in your book, is it there? Yes. Can I take out page number 54, please?
54. Yes.
Okay, so we have one scale. This scale is basically called as electromagnetic spectrum because we arrange the rays in their increasing wavelength. So you can see that X-rays are 10 to the power minus 10. Okay, then far UV rays is 10 to the power minus 8. So when in the medical field, when they are taking X-rays, they use these wavelength radiation for the X-rays because X-ray these wavelength which have less frequency can penetrate into our body and give the information about the bones and everything.
Okay.
Got it?
So they have to use less frequency only. They have to use less frequency. Like
Yeah,
less frequency. Yeah.
less frequency.
Yeah. Less wavelength actually. Less wavelength.
Less wavelength.
Less wave.
Okay,
Less wave.
so basically you can see that x to the power, no, I'm saying wrong. The frequency should be more, na, then only it can penetrate.
Yeah. Frequency should be more and wavelength should be less.
So basically in your book it's starting from right side is lower and the left side is more.
If that's for frequency.
Let me check it. Hmm. Wavelength should be less and frequency should be more, na? Yes, correct.
Wavelength should be less,
Ah,
frequency should be more.
frequency should be more so that it can penetrate and it can give the information about our body inside the body. Okay, and
Yes,
in the right side you can see that the wavelength is more and the frequency is less. That's why it is called as far infrared. Like in the TV remote, we have that bulb, no, that releases far infrared. So we cannot see these rays, either UV light, X-ray rays, far UV, far infrared, near infrared, microwave. We cannot see these rays because they are not in our visible spectrum. Visible spectrum means we can see this color only. Correct?
yes, sir.
So if we are getting red color, so the red color is wavelength is 750, okay, which is the higher side. Okay, the longest wavelength of a visible spectrum is 750, which is the higher side. Did you understand?
Yes,
Say
sir.
yes or no?
Yes,
Hmm?
sir. So,
Now,
so wavelength is measured in nanometer, right? So there's so many units. You have nanometer, you have picometer, and you have angstrom also.
Angstrom also, correct.
Okay.
Okay. Now, we'll write one thing. Hmm. Write it down one thing. The electromagnetic radiation, the electromagnetic radiation also show the characteristics of particle. Electromagnetic radiation also show the characteristics of particle. These are called quanta, which are called quanta. These quanta, these quanta are actually
Right. The electromagnetic radiations also show the characteristics of.
particle.
Yes.
These are called quanta. Quanta. These quanta actually bundles of energy, bundles of energy, full stop. A quantum of visible light is called photon. 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 The energy of quantum or the photon, the energy of the energy of photon or quantum is directly proportional to the frequency. Is directly proportional to the frequency. So more frequency is there, more energy is there in that. So okay, I'll ask you this question. When we go in on the outside, we have sunlight, and sunlight is a light, no?
Yes, sir.
Okay. If that sunlight will fall on us, what will we feel?
We'll get tanned.
We get tan, and even we will feel that some hot things, okay, some hot things is on our skin. Why? Because the light has the small packets of energies. That energy is called as photons, and that can be calculated based on the frequency. If more frequency is there, then more energy will be there. For example, which will have more energy of packets, the red wavelength or the violet or the violet wavelength, violet color, sorry.
Right.
The red color will have more energy or the violet color will have more energy?
Violet.
Violet. So if that violet, because violet is violet color light will when it fall on you, you will feel more energy as compared to the red color. Did you understand? No.
Yes, sir.
Okay. So from this we can conclude this. From this we can conclude this that E is directly proportional to frequency, which is mu.
Yes.
Okay. And if I will remove this, then I will get H mu. Okay. H mu. H mu. Okay. That proportionality sign which I removed and I got the H. This H is called as the which constant? You
Planck's
know?
constant. Planck's constant.
Very good. Planck's constant. And Planck's constant is a value called as 6.626 into 10 to the power minus 27 erg or 6.626 into 10 to the power minus 31 erg second, okay? Erg second. Or 6.6 into 10 to the power minus 34 joule second.
Yes.
Joule second. Okay, so we never use the erg part. So instead of that, you can remember this part, joules part.
Yes, sir.
Okay, did you
So,
understand?
yes, sir.
Hmm.
So the Planck's constant is used in like most of atomic structure, like is used in like calculating the de Broglie wavelengths. Then
Yes,
is also used in like calculating the like energy. Then yeah, like Planck's constant is used in most of the sums in atomic structure.
correct, correct, correct. Okay. Now, if they ask you to find the relationship between the energy and the wavelength, then what will you do? What will you do? So we know that C is equals to lambda by mu, lambda into mu, sorry, lambda into mu.
Yes,
So C by lambda is equals to mu.
yes,
I'll put the value into this. So I got one more formula, which is E is equals to Hc by lambda. So on the based on wavelength, energy is also there. Less wavelength, more energy will be there. So who has less wavelength? Violet has less wavelength as compared to the red. So energy of violet will be more as compared to the red.
yes, sir.
Did you understand?
Yes, sir.
Okay. So, yes, write it down, beta. And in terms of wavelength, what formula you can make? Wave number.
Yeah.
What formula it will be?
E is
E
equal
is
to
equals to
nu bar or Hc
mu
lambda
bar.
dash. Hc lambda
Yeah.
dash or Hc nu bar.
Or nu bar. Okay, you can use that. Shall we do some questions?
Wait, 1 minute.
Yeah, yeah. Take your time. For you, I have three books. The NIS book, one all-in-one book, and one more guidebook. So because I am concluding all this to teach you.
Sir. I thought you had
Yeah.
the NIS book, the CBSE book, and the ICSE book.
Yeah. No, no, not ICSC one, but CBSE based also there, as well as NIS guide is also there, and NIS copy is also, NIS book is also there.
Yes.
So I am concluding all this thing to teach you.
Oh.
Because in some, like for example, in your book, there is no word Planck's constant is there. If you will check that, there is no H. Just said H, and in the example they use their value. Now, what is H? Where is the H? They didn't mention right now. So then if I will teach you or if I will some teach anybody, What is the edge? So from that I took that guide. So I mean I am taking all the information and giving it to.
Sir, so
Okay. Yes.
H. Okay. So H is Planck's constant, and Planck's constant is this one. Yeah, the Planck's constant is this. The H. And H
Yes.
equals to 6.626 into 10 to the power minus 34 joules.
Correct. Correct. Yeah. So now what is the question is saying?
The green light has a wavelength of 535 nanometer. Calculate the
Mm.
energy of a photon of green light.
Can you solve this, or you want me to solve it?
Sir, so you know what?
Yes.
In Allen, they said that there is another formula to calculate the energy.
How?
Energy is equal to 1240 divided by lambda wavelength in the nanometer. E
1240 divided
divided
by
by
the
the,
wavelength in nanometer.
yeah.
Okay.
Welcome. 1240
Okay.
divided by 535, and the energy units will be in EV, electron volt.
Electron volt. Okay. 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 Okay.
Eh, eh. Electron volt.
But I mean, you can use in the MCQs one, but in NOS you can't use. Okay. Why? Because there is no formula. They will say, what is this? What is that? They will cut your marks. Instead of that, see, LN is for G advance. You have to keep this separate, okay? LN is for G in advance, and this NIOS is for NIOS. Or if you are going to see, I am saying with my experience, that is why. I went to Akash. I did this mistake that I mix up the school as well as the 11th, 12th as well as the Akash. Okay, so in 12th class I didn't did that, but in 11th I mixed it up and I lost my marks.
Oh, so in 11th class you lost your marks, not 12th.
Yes, not no. 12th I got good marks because in 12th I got that I'll take one year drop to the cover the 12th course, but I will not mix it up because I'll get less marks in 12th and then.
And then you again joined.
Yes.
You again after you finished the 12th you joined.
No, no. After finishing the 12th, what happened that my father passed away, and then we don't have that much expenses for the coaching classes or for the medical exams fee and everything. So I pursue first teaching, and then I did my graduation in BSc,
Oh, and then
Bachelor in Science.
only you founded of the NXT and
Yes,
you met
yes,
this one Rebecca ma'am and Sakshi ma'am and all this.
yes,
Okay.
yes. Okay, so we'll do this question.
Green light has a wavelength. Green light. Okay. So we're going to 535. Okay. So now E is equal to Hc by lambda. Yeah. Do we have to use E is equal to Hc by lambda only for NIOS? E is equal to Hc by lambda only.
Yeah, HC by lambda.
Done, sir.
Done. What answer you got?
3.72 into 10 to the power minus 19 joule.
Correct. Correct. Okay. So we learn about electromagnetic spectrum. Okay. Now, write it down. There are there are two types of
Yeah.
there are two types of spectrums are there. There are two types of
Spectrum.
spectrum. You are getting the what is spectrum? Spectrum is
Oh,
arranging
yeah,
them.
yeah, band. Like a band of light.
Yeah, bands of light. Okay. So there are two types of spectrum. First is continuous spectrum. Okay, first is continuous spectrum,
Yes.
and the another one is discontinuous spectrum. Discontinuous spectrum. Okay. So what is continuous spectrum? Okay, we know that when sunlight, okay, when sunlight will emit the light, okay, that sunlight when rain is going on, then it creates rainbow.
Rainbow.
Yes,
Yeah.
that rainbow is like the colors red, sorry, Vibgyor, no, violet, indigo,
Blue,
uh,
green, yellow,
blue.
orange, and red.
So these spectrums, there is no defined line is there. Like in drawings, we used to make a line, but actually the lines are not there. Okay, so these spectrum are called as continuous spectrum because there is no line in there. Okay,
Yes.
and in atomic structure, like source of any white light instead of sunlight, when we put them in the discharge tube and when we pass to the prism, we get discontinuous spectrum. Discontinuous spectrum is gonna be look like this: that color, then black part, then color, then black part.
Yes.
So that black part makes that spectrum discontinuous. That is called as discontinuous spectrum.
Yes, sir.
Okay. So there are like light bands and dark bands, light bands and dark bands. So this is called as discontinuous spectrum.
Yes, sir.
Ignition.
Yes, sir.
So we'll write it down about this. Below the continuous spectrum you have to write, and then if I will say then below the discontinuous spectrum you have to write quickly. A continuous spectrum. A continuous spectrum is a spectrum where pattern of diffuse glowing bands where pattern of diffuse glowing bands merge into each other merged into each other, then discontinuous spectrum, write it down,
Uh, diffuse glowing bands.
merged into each other, then discontinuous spectrum.
Not yet done, sir.
Huh?
Almost done.
Okay.
Done, sir.
Okay, next one is discontinuous spectrum consists of consist of separate consist of separate and and unmerged spectral lines. Unmerged spectral lines.
Yes, sir.
Now write one more point. Solar spectrum is an example of continuous spectrum. Solar spectrum is an example of continuous spectrum, and atomic spectrum is an example of discontinuous spectrum. Atomic spectrum is an example of discontinuous spectrum. Do you have any doubt?
No, sir. No doubts. Doubt illaye.
Okay. Doubt, like very good. So this is the spectrum, and we will work till here only. I believe we did the line spectrum also. Then on Monday, okay, so because the wavelength varies, it will pass. Okay, so continuous spectrum, and that is line spectrum is also said. Okay, this continuous spectrum is also called as line spectrum,
Line spectrum and band spectrum. Both are there.
band spectrum. Okay, so write this continuous as line spectrum also. And in the line spectrum, will you just remind me? You put a heading and remind me, sir. On Monday we have to do this. You used to say line spectrum of hydrogen atom. Line spectrum of hydrogen atom. So line spectrum basically gives us clarity, okay, that if light is there, okay, if we are calculating the wavelength of where to where of the charge particle, we can get an idea of how much energy required and all this thing. Continuous spectrum, like because the lines are merged, we are not able to find which part of this, which of part of that, but line spectrum gives us, or discontinuous spectrum gives us this thing.
Yes, sir.
Correct?
Yes, sir.
No. Okay, I know that you have learned, but my work is to teach you again, so that's why. Mhm. Okay, so but you are getting, na?
Yes,
You are
sir.
getting? Okay, okay. Perfect. So we will start our Monday class from line spectrum of hydrogen atom.
Yes, sir.
Okay. So I hope you have enjoyed the class. Till then, bye. Have a nice day. Signing off, Varshabak here. Sayonara. We'll meet
So,
on Monday.
my next test will be on Wednesday, right?
Wednesday.
The chapter one test for me.
Chapter 1 test.
Okay, sir. Bye,
Perfect.
sir. See you
Bye.
on Monday.
Bye. Bye.
See you on Monday, sir.
Bye. Perfect. We'll see you on Monday. Bye. Guys, just give me 1 minute. We'll start the class. Yes, guys. Good morning to all. Agatha, Joshua, Vidya, good morning.
Good morning, sir.
Very good morning. Very good morning. So, uh,